All right, let's start with a quick review for our 7-3 notes here. The review concept is this. What is a unit circle? All right, if you answered correctly, your answer should be a circle with a radius of 1 centered at the origin. Okay, so this right here is a unit circle. We're going to use it as a unit circle at the very least, and it is centered at 0, 0, and it has a radius of 1. So that said, what we're going to do next is we're going to talk about circumference. Now this also is a review concept, but you may have forgotten how to find circumference. So I'm going to do that down here real quick. Okay, circumference of a circle is found by taking 2 pi times the radius. Okay, or pi times the diameter. So what we're going to talk about today is a type of unit called radians. Okay, and the definition of a radian is essentially the amount of arc that is traversed on a unit circle for any given angle. That's a really complicated definition. So what we're going to do is we're going to give a little bit of teeth to this by showing you what this would mean. So if you remember when we did the unit circle before, we talked about degrees. So if I had a point out here, this would be at 0 degrees. It goes through. This is 90 degrees. We get all the way over to here, it's 180 degrees. And 270 here, and then by the time we get back around, it's 360 degrees. All right. So what we're going to do is we're now going to talk, instead of by degrees, we're going to talk about parts of the circumference. Okay, the circumference would be from here all the way around the circle. That would be the full circumference. So if I haven't gone anywhere, if I've gone 0 degrees, then my circumference, or my radians, is also 0. Again, that's 0 radians. But if I've gone all the way around the circle to here, then that would be the whole circumference of the circle. Now, my circle, remember, has a radius of 1. So if I take my circumference formula and we do circumference is 2 times pi times 1, then the whole circumference of this circle is going to be 2 pi. So when I say 2 pi radians, it's the same as saying I've gone 360 degrees. These are two different ways to measure the same thing, and that's the most important thing you need to remember. These are two different types of units that are pretty much measuring the same thing. One of them measures the angle from the center. The other one measures the amount of arc length traversed in a unit circle. All right, so now that we know this is 0 and all the way around is 2 pi, we should be able to start filling in some of the pieces here. All right, now remember, 2 pi, this isn't just like, some random thing we call pi. We have a definition for pi. Pi is approximately 3.14159 and so on. So when we talk about 2 pi, I'm literally talking about 2 times this number. So this would be around 6.28 and a little bit of change. All right, so just remember, all the way around would be 6.28 of these units that we call radians. All right, so now that we've said that, let's find some other parts. So if I go halfway around the circle, how many radians would that be? Well, that would be pi radians, because it's 2 pi to get all the way around. And half of a circle would be just 1 pi. All right, well, what if we go a quarter of the circle? How many radians would that be? Well, that would be half of pi, or pi divided by 2. How many would this one be? How would 3/4 of a turn be, or of a circle? Well, that'd be 1/2, 2/2, 3/2 of a pi. So 3 pi over 2 is how we're going to write that. All right, so now we have that. Let's put some numbers to this. So out here at pi, remember that's 3.14-ish units. So 3.14 radians, 14159, blah, 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 blah. That's the number of radians that's out here. Okay, this one would be half of that. Half of that. So this would be approximately 1.57 radians. And this one would be, like that plus that. So that'd be 4.71-ish radians. Okay, 4.71 radians. Again, these are obviously approximations. All right, so now we kind of have an idea. This is about 1.57. This is about 3.14. This is about 4.17 and about 6.28. So if I were to ask you to find or to approximate where 1 radian is, where would you put that? Where would 1 radian be? Well, it wouldn't quite be to here. That's 1.5 radians. It'd be past half of that, because half of 1.5 is about 0.75. So about here is 1 radian. Okay, so hopefully you're kind of getting an idea now of what a radian is and kind of how it's used. All right, now pretty soon we're going to start talking about special angles of the unit circle, ones that are kind of easy to find. One of those, for instance, would be the radian measure for 45 degrees. So if we pretend that this is a 45-degree angle, then that means that the radians here, my arc length there around the unit circle, would be half of a half pi. So this would be 1/4 of a pi, pi over 4. And so then when we go over here, and again, you have to pretend that that's a 45-degree angle there, this would be this would really be 135 degrees if I go this direction. Okay, 135 degrees. And at 135 degrees, my arc length would be 3 pi over 4. Okay, this is 1 pi over 4, 2 pi over 4, 3 pi over 4. And we can kind of keep going along in that pattern. All right, so that just gives you a little bit of a preview of something we're going to be doing soon. We will use those angles pretty readily. All right, so then one of the things we have to be able to do is we have to be able to convert between radians and degrees. Okay, so there's a couple different ways to approach this, but I'm going to approach it with something that my students all tend to do pretty well. So here's what you do. You take 2 units that are comparable. This goes back to unit analysis you've done before. So I'll give you an example of this. You know that 1 yard equals 3 feet. Or at least you're supposed to know that. So if you know that 1 yard equals 3 feet, then if I'm trying to convert from yards to feet, I can say, for instance, if I have 20 yards, and I don't know how many feet that is, I can set that equal to, well, I know 1 yard is 3 feet. I make a proportion. And so now I can cross multiply and I get 60 feet yards. I know it's going to look a little silly, but I get 60 equals X. All right, so now I know that 20 yards is 60 feet. So we're going to do a very similar thing with radians and degrees. We could do 2 pi compared to 360, but we can trim that down a little bit by comparing pi and 180. So pi is the radian measure, and 180 is the degrees. Those two represent the same angle. Again, these are just different units measuring the same thing. So now I can figure out, for instance, if I have 240 degrees, and I want to find how many radians that is. Well, then I just put 240 degrees there, and then I put x radians here, and I'm going to cross multiply. Now, if in this case, if I'm trying to solve for x, I probably just need to multiply both sides by 240. So that's going to be 240 pi over 180 equals x. And then I am going to reduce that fraction. So cancel out the zeros by dividing by 10. I can divide by another 6, and that's going to give me 4 pi over 3 when I reduce it. So my radian measure for 240 degrees is 4 pi over 3, also known as 4/3 pi. All right, so hopefully that can kind of makes sense. We could do the very same thing with if we know the radians and we're trying to get degrees. So for instance, going back to the pi over 180, so I know pi compares to 180. And let's see if we can figure out how many degrees 1 radian would be. So equals 1 radian over, I don't know how many degrees. So we're going to cross multiply. So pi times x equals 180. And then x would equal 180 divided by pi. All right, so if I take 180 and I divide by pi, that should tell me how many degrees makes up 1 radian. So 180 divided by pi is right here, second function. All right, so it's about 57.3 degrees. Okay, quick question. Which of the two answers that I just got is the exact answer? Okay, this one would be what we call the exact answer. This one, it was 0.295 and stuff. This is an approximate answer. So if I ever asked you to find the exact answer, this would be 180 divided by pi degrees, which sounds totally weird, but you just have to understand that is technically the exact answer. And then this one would be an approximate answer for that situation. All right, so hopefully you're still with me here. Again, we'll have time in class if you have questions on that. So now let's go to the concept of finding arc length in a circle. So if I'm dealing with a circle and so I'm just gonna make a circle here real quick. All right, so if I'm dealing with a circle and I want to find, let's pretend, there we go, that'll help a little bit. I want to find the arc length covered by this angle. So let's say that angle is 135 degrees. Okay, I know I went backwards in my angle here, but that doesn't really matter. I'm just trying to find the arc length of this right here. If I want to find that arc length, you really only need to know two things. You need to know the angle in radians, and then you need to know the radius of the circle. We don't have the radius of the circle labeled, so let's just say that it's 5. Okay, so I have a 135 degree angle. I have a 5 unit radius for my circle, and I want to find this arc length. All right, so here's the cool thing. Arc length has a very simple formula, and it is S equals R theta.